Now coming to the concept of creating a system level test bench. So uh, whenever you are creating a complex or complete test bench, you are saying, so what all the things we need to consider is, first is the corner cases. So we should keep all the corner cases in our mind. Then we have to check some boundary conditions. So boundary conditions means like 5 for full condition, 5 for empty conditions. Like at the boundary, at the ends, you have to check the conditions. Okay, so that is what they are talking about, boundary conditions. Then we have to go to these design discontinuities. Okay, so if any discontinuity is there in your design, you have to uh, check all those things. Means there should not be any design discontinuities. Okay, error conditions. So if you are forcing error conditions, like suppose you are sending a wrong CRC on the on some data. Okay, so during that time, how your device is behaving, so you have to check the behavior of the device during that time. So in every protocol, as we know that there is one exception case, like at uh, uh, definitely every protocol different from other protocol in some way, like some exceptions are there in a specific protocol. So you have to careful handle those exceptions. Now coming to system level test bench matrix. So the so what they are trying to say from his, uh, actually when you are creating a test bench, okay, so you have to create the test bench at the um, top level you said at transaction level, or you can say at behavioral level. Okay, so the first measure is whether or not all the tests defined in the verification plan are included or not. So after developing the bus function models, or you can say monitors or stimulus generators, you have to check all the things, like you have defined some test plan. Okay, like you are going to see all these test cases, whether your duty is working with this or not. So you have to check those test cases. So you first you have to check whether you have included those things in your test bench or not. Okay, so this is the qualitative measure rather than truly quantitative one. So this is the quality, this will tell you the quality of your test bench. Okay, if the attention was paid in the definition of the verification plan, then this is worthwhile metrics. So if you pay some attention at creating during verification plan creation, then it is much more better. Okay, so uh, they are telling that at the abstract system level, C++, VCC, system C, the industry is interested in defining and measuring functional coverage that measure how well a test bench exercise the purely functional model of a design. So whenever you are writing some functional coverage for your design, okay, so you will write at top level, abstract system level. So either you will write with C++, or VCC, or you will write with system C. So these are some of the system level specifications or system level language by which it is easy to write the functional coverage. Okay, so we know that functional coverage we will write after reading the specification, right? After reading the specification, we have to write some coverage for coverage in order to check whether designer has implemented all the features that are present in the specification or not. So that thing we can catch with the help of functional coverage. So while this area has attracted much interest, it has not yet resulted in definitive tools, although it does offer hope for the future. So they are telling that this is the most vibrant area in the verification, but still we don't have many standard tools so that we can work with functional coverage perfectly. So when possible, test all the possible combination of a transaction with all possible data set. So they're telling that when you're enabling a transaction, okay, so what you will do, you will not check all the data fields, right? You will use data field as a random. So if they are telling, if at all is it's possible, you force each and every data set. Okay, you check each and every combination of the data set. So for large design, this result in excessively large test benches. But if you are telling that if you are going to check for each and every data, means it will your test bench will be very your test bench code is going to be very too much. Okay, so what they are trying to say from this is like when you are checking the data, basically what we have to do, whether you have to send all the ones, all the zeros, or you have to go with walking ones, walking zeros, okay, with the 1010 sequence. Such type of data you can transfer when you are going with the data transactions. Okay, no need to specify all the, if 8-bit data field is there, no need to specify all 2 raised to power 8 possible combination. But in case of, if that is a control information, during that time you have to check each and every bit with respect to that. But in case of data, there is not much problem. So apply knowledge of the design to limit the test bench size to a manageable level by excluding redundant tests without sacrificing the quality of the test. So what they're trying to say is that if you are changing each and every data bit, okay, so in that case your test bench size will increase, and that test bench is not manageable, okay. And at the same time, the quality of the test, you should ensure the quality of the test, okay, so that quality of the test will degrade. So that is what they are trying to say. So query that simulation database, the log the result of multiple simulation to test if the transaction test requirement have been met. So what they're trying to say is, after getting the output from the DUT, right, you will get output in form of log files, okay. So you have to check whether your transaction is met or not, whether your whatever you required, what was the requirement for the transaction test, whether you met that thing or not. You have to check all those things. So now they are telling that at the hardware description language, a variety of tool measure code coverage, the types of metrics. So they're telling that if you're writing your test bench with the help of any Verilog or VSTL, okay, so you can measure that with the help of. So what all the coverage matrices we are having? We know that we are having statement coverage, okay. We have to check whether our test case has verified all the statements in our design code or not. Toggle means